Yes, today I would like to show the exercise we have done for DocDB SQL for the group by. So first, we would go to the path, which is, this is the correct path, video code along 07 group by. Once you are in the correct path, you will need to create a DocDB. Can rename this as, what is a good name for this? We can do it food data DocDB. And then we're going to ingest this ingest food file. So we're going to ingest it by writing the path, which is from SQL ingest underscore food dot SQL. And then in the ingest food dot SQL, we have this create a table. And if it doesn't exist, create a table named as food. Select everything from this path, which is the data that has the food search Google CSV. And the way of importing is we're using the read underscore CSV auto. So I would like to ingest that. Once we have ingested it, I'm gonna create my docdb UI. Dash UI, we can call it food data because we have named the docdb food data. So it has to be the same dot db. We will be opening the UI here. Now that I would like to share in a bit. Now I would like to share the local UI, which is this one. Great. Now we can create a new notebook called food underscore data. And then if we are going to look at the database, we have a schema for the main. We have not created a staging schema for now. And we have the food table that has an ID column with a varchar type, Google topic varchar type, week ID, and a value. Now, yes, correct. So now we can do the first query. So we just need to get familiar with what's inside the food table. So the queries get the schema, review all data, look for distinct food items IDs, check how many unique foods and total records there are, and we need to filter the data for data ranges. So to be able to do that, we can first get the schema of the table. So you describe food data. Oh, yes. Because of the name of the table is food. So we will describe the table food. And then we have these 4 columns. Next, we can explore the data from food. So we can try from food. And then here we can see that we have some frozen yogurt. It's how many thousands rows? It's 50,000 rows in here. We have beefsteak. So what if we want to see? It will take a lot to check one by one what kind of food this is. So we can get distinct IDs. We can do select distinct. What do we want to get? ID from the food table. So here, these are the foods that we have. We have Easter egg, cheeseburger, salmons, and then going down all the way to, we have how many? 201 rows. So it means we have 201 different foods in our food table. Next, we can count these distinct IDs, which is 201 different food items. We can count how many we have. It should say 201, but we can just still query it. Distinct. What are we gonna count? This distinct ID from food. Oops. Oh, sorry. So we're not supposed to. Why is it? We count. Select the count of the distinct IDs from food. So yes, we have 201 here. As you can see, if we look here, it is also 201 rows. We can also count the number of rows, which we can do select count, and then we can count everything. And what are we gonna name it? If you want to create a new row for it, number of rows from food. You select everything as a new table called number of rows. And now we have created a new column called number of rows, and this shows the number 135,025. We can also filter data for weeks, let's say between April 2024 and June 2024, so 2 months. We can filter data for weeks. So what kind of foods are there between these 2 months? So we can select everything from food, and then we use the where statement to filter week ID. Remember that we have a column called week ID. So we're going to use that. And then we're going to use the between statement, and 2024. Oh no, sorry, not 2004. It's not 2024, it's 2004. So we can do 2004 April, between that and 2004 of June. So we have returned 581 rows, and these are the orders or the data of food between those days. Next, we can do we can actually do another task, which is we can create a few goals in here. Goals 1, change name of ID into food. So we're going to change name of ID into food. We can also remove Google topic column. So this column is not being used, so we can remove that. Remove Google topic column. We can also change the value, change this column called value into number of searches. Change value into, we can change name of value into number of searches. We can do also change the week ID name into week. Week ID name into week. And then we can also extract a year column so we know which years it was the available was available. So extract year column. Yes. So we can start with our goal number 1. So if we're able to change the name of ID into food, we can do aliasing by using the query as. So we can do select. What are we going to select? ID as food. This is aliasing. We're going to change the name of ID as food. We're going to change the name week ID as week. And then we can also extract year from the week ID. We can do that by using a substring function. And the arguments would be from instead of indexing in Python that starts from 0, in SQL it starts from 1. So there are 4 index 1. If it's 2004, we start from the index 1, ending from the index 4, and we rename that table as year. We can also rename this column at the same time by aliasing number of searches. Where are we going to get this data from? We're going to get it from food. Let's see. Now, yes, we have created a new column called year that we extracted from index 1 to index 4. And we have also created a new column for the number of searches, which we just replaced from the old name value. Next, we can actually do a final transformation query to create a new cleaned table. So this is a bit messy. This table is a bit messy. So we can transform a query to a new cleaner table or cleaned. We can call it cleaned table, cleaned food table. So we can do that by creating a new table. So we create table if not exists. If not exists. What are we gonna name it as? We can name it as we can do it like this, as cleaned food table. And then where are we gonna get the data from? We can select everything. ID as food. We're gonna get the ID. We're gonna get this ID as food. We can do the week ID as week. Can do it this way actually. You can do a substring. I'm just redoing everything as year, as number of searches. From food. Let's see. I believe there's gonna be an error. Right. What if... Let's see, because I would like to create... okay. If not, create table. If not exists, the name should be here. Cleaned food table. Table. Us. Yes. Let's check. From clean food table. Let's see if I has been successful in creating that. Yeah. Now this is the new table, just called cleaned food table. Then I was thinking that we can also try to understand the group by. So we would try understanding group by. Understanding group by. So the goal would be to each food category. Each food category, frozen yogurt and pizza, may appear many times in the table. We can collapse all rows of the same category into one row per category. We can also aggregate the number of searches column to understand total search volume, and we can use the sum function, the aggregation function, to add up all searches in one category. So we'll just copy paste the goal. Now let's see here. Yes. So we can use the food category column as the grouping key, as you see here. And all the frozen yogurt rows will be grouped together, all pizza rows grouped together, etc. And then we can also choose the metric to aggregate. So we can use number of searches to aggregate that. And then we can also apply sum to the number of searches to calculate the total searches for each category. So we can do the group by now. Let's see what happens. So for task 1 is aggregate total searches per food category. A total searches per food category. In total. So what we can do is we can select food. So we would like to name, no, we would like the total number of searches for the number of searches, this one, we would like to know the total per category. So what we can do, we can do sum. We can do number of searches and name that new column as total searches from from cleaned food, the new cleaned food table. And then from here, once we have collected the total number of searches in this function, we can group by. How are we going to group by the results? So we could do group by food category to summarize them into single rows. Group by food category to summarize them into single rows. And do, how are we going to categorize? We want to categorize them by food. And how are we going to order them? We can order by the least. We can order by descending order. And total searches, I want total searches in descending order. And we can also limit it to 10. And let's see. Okay, so we have created a table called total searches, which is just the sum of all the number of searches. Here, we have grouped them by food, and the limit is 10 in descending order. So we can see that sushi has the most searches of number of searches, and meatloaf has the least number of searches. What if we want to search by year instead of food? So what we can do is instead of food, we can do select year, can do the sum of as total searches from cleaned food table. We can group it by year, or we can order by total searches. So here, if we're going to compare, we have grouped the total searches by food, but if we're going to see by year, we can see that 2004 has the least total searches, and then it goes upwards as 2016. Well, the reason for this is that because of maybe when the internet was first created up to the point of the iPhone and social media. So as you can see, as time goes on, the number of searches has been rising year by year. We can also do filter. We can also filter by the total search greater than 300K. So we could do, we're going to select the years. Yes. And the sum will be still the number of searches. from clean food table. We're gonna group it by year. And we're gonna use having to show that only total searches that are greater than 300K. And order it by this. We can actually order it by ascending, but it is automatic if you do not provide. And you can order it from the total searches column. Let's see. Yes. So now all the years that are more than 300K is shown, and it automatically shows by ascending order. Then we can also we can group by 2 columns. We can do it with year and food. So we're going to do year, food, and the sum. Here we can have it, we can have it on the next row. Sum of the number of searches as total searches from cleaned food table. Can also group it by year and food. Having we can say that we want 2 foods, so we can do food we want pizza. Actually, if we want to, it should be in parentheses. Pizza, sushi, and we can order it by food and year. Year, right. So here we can see the total searches by ascending order. And yeah. Yes, and we can see that throughout the years, sushi has become more popular. So that is the group by lecture that I am trying to review.